Hi my dear students. In this tutorial session, I'll be explaining about the properties of, that is basic properties of real numbers. The real number can be represented as R. You know, there is a R that includes a rational number as well as irrational number. Is it not? Right. Now, we have around 9 properties of real numbers. Let me discuss one by one. So we have closure law, commutative law, associative law, additive identity, additive inverse, multiplication identity, multiplicative inverse, distributive law, trichotomy, then transitivity of order, monotone addition as well as multiplication. Right? So we have these 9 sets of properties, that is the basic properties of a real number. Let me discuss one by one with a suitable example also. For example, let me take the closure law. So here, before that, let us say A, B, C all belong to, that is, real number. Okay, right. Now, when I say A plus B, you have to consider the any two real number. So A plus B, for example 5 plus 3, that is closed. So 5 plus 3 means 8. 5 minus 3 is equal to 2. So A minus B. 5 into 3, that is A dot B, A into B. And similarly 5 by 3 or 5 by 2, anything. So that belongs to, the result belongs to real number only, provided the denominator should not be 0. Okay, so you will get some closed numbers only based on this. Now, commutative law. In the case of commutative law, that is A plus B is equal to B plus A. For example, when you take 5 plus 3, that is equal to 8. When you put 3 plus 5, that is also 8. Okay, so it gives the same result whether you interchange. Okay, A plus B is equal to B plus A. And similarly, A dot B, that is multiplicative. A dot B is equal to B dot A. This multiplicative property is commutative. Okay, so you can interchange and you will get the same result. For example, 5 into 3 is equal to 15. 3 into 5 is also 15. Do you understand? Right. Then associative law. I would like to share one important one. When I say 10 divided by 2, that is division. 10 divided by 2 is not equal to 2 divided by 10. Are you able to understand? So this operation is, that is commutative law, is applicable only for addition and multiplication, not for subtraction and what? That is division. For example, when I take 5 minus 3, you cannot say that is equal to 3 minus 5, because 5 minus 3 is equal to 2. 3 minus 5 is equal to minus 2. You cannot claim that 2 is equal to minus 2. So, for subtraction, commutation is not possible. Similarly, for division, it's not possible. But for addition and multiplication, commutative law is feasible. Okay. Then similarly, associative. Associative means, that is, these elements can associate either as a pair of the second one, third one, or first one, second one. For instance, A plus of B plus C is equal to, now in this case B and C are associative. Okay, and this can be associative. A and B also can be associative. So A plus B of B plus C. What do you mean by that? That is, you can, according to Bodmer's concept, that is, you have to solve the element, operation within the bracket. So you have to solve B plus C and then you can add with A. Similarly, here A plus B can be solved and then you can add to C. So this kind of property is called associative law, and this is feasible with addition and multiplication, but ruled out for division and subtraction. And that is why we have taken only addition and multiplication. So A dot B dot C means you can multiply B dot C, B into C first, then multiply by A. Whereas that is also equal to, you can multiply A and B and later multiply by C. So this kind of property is called associative law. But these two operations are feasible, can be governed by associative law, but not subtraction and division. Then additive identity and inverse. Additive identity means, for example, let me take an element A that belongs to R, that is real number. So A plus 0, either 0 plus A, that gives A, that is, it gives the same number by addition. So in that case, a 0 is called the additive, that is the identity of the element A. Do you understand? Right. And similarly, in the case of inverse, for example, A plus B is equal to 0 and B is equal to minus A. So this B is equal to minus A is the inverse, additive inverse of that particular element. Then multiplication, and similarly you have identity multiplication and inverse multiplication. So multiplicative identity means when you multiply 1 by A, you will get the same number. Okay, so it's called additive. So in that case, this is the identity of, not additive, identity of multiplicative. Okay, multiplicative identity of A. Which one? 1. Okay, because when you multiply by 1, you will get the same result. Okay, for example, 5 into 1, 5. 10 into 1, 10. In that case, 1 is called multiplicative identity. And similarly, A dot B, that is A into B, is equal to 1. Okay, so in that case, B is equal to reciprocal of A, that is 1 divided by A. So here, that is B, that is equal to 1 by A, and that is what? Multiplicative inverse. Okay, then distributive law. Distributive law in the same sense, that is A dot B plus C is equal to A dot B plus A dot C. Okay, so this multiplication is distributed to B and C like this. Okay, so this is called distributive law. And trichotomy, for example, when you take any two real numbers, here A is greater than B and A is equal to B and A is less than B. So all lie within these three operations only, three symbols only. Okay, and this is known as trichotomy. And transitivity of order, for example, A is greater than B, B is greater than C. In that case, A is greater than C. For example, let me say 3 is greater than 2, 2 is greater than 1. Definitely 3 is greater than 1. Okay, and that's why it's called transitivity of order. And what about monotone? Monotone addition. Monotone addition means, for example, A is greater than B. Okay, so in that case, let me add C on both sides. So the result is also greater, that is LHS is greater than RHS. That is A plus C is greater than B plus C. And similarly, multiplicative monotone. So monotone multiplication means A is greater than B. Now let me multiply C on both sides. So the results are also same. That is AC is greater than BC. Are you able to follow? So these are all the important 9 properties of, basic properties of a real number. Okay. So thank you for watching this video, and I will proceed with complex number, the basic properties of complex number in the next session.